Okay, here we apply the accumulation point theorem to some examples. Now, given that we are finding limits as x, y approaches 0, 0 of x squared minus y squared all over x squared plus y squared. We want to find this limit. Now, here my point P is xy and A is 0, 0. Now, if the limit exists, then it must be equal along all the lines that pass through the point 0, 0. Now, that is accumulation point here. So let's see. Let's look at limits along the line x is equal to 0. I. Now, along x is equal to 0. X is 0. Watch carefully. X is 0. Along the line x is equal to 0. So in place of x, I'll put 0. So the function becomes only a function of y. So I have limit as y goes to 0 minus y squared over y squared, and this is equal to minus 1. I. Now I check limits along y is equal to 0. Now along y is equal to 0, in place of y I'll put 0, 0. And it becomes only a function of x. So I have limit as x goes to 0, x squared over x squared, and this is equal to 1. Good. Now, we could see that limits along x is equal to 0 gives me minus 1. Limits along y is equal to 0 gives me 1. So I conclude the limit does not exist. Because if it were to exist, then it must be equal along all the lines that pass through 0, 0. But in this case, it's not happening. So we claim that clearly the limit does not exist. Okay, the limit does not exist. This is example 1. Nice one. We'll take another example. We'll take another example. Let's look at f of. We look at example 2, and here we are checking for limits as x, y approaches 0, 0. 2x squared y over x squared plus y squared. We check this limit. Now, what do we do? By the accumulation point theorem, if the limit exists, then it must be equal along all the lines that pass through 0, 0. So first, we know the line, we check along x is equal to 0. Like the first example, if x is 0, we put 0 in place of x, and we get limit as y goes to 0, 0 over y squared, which is equal to 0. We check along the line y is equal to 0. And along y is equal to 0, I will have limit as x goes to 0, Now if y is 0, the top becomes 0. So 0 over x squared, which is also 0. Next, I check limits along the line y is equal to x. Now if y is equal to x, in place of y I'll put x, and that will give me limits as x approaches 0. Here I will have 2x squared times x all over x squared plus x all squared, and this clearly becomes limits as x approaches 0. Limits as x approaches 0. Two x to the power 3 all over 2x squared. And clearly this will give me, let me please clean the top because we've seen these ones already. I'm getting limits as x approaches 0, x of x. Alright, and once x is 0, this will also give me 0. It will also give me 0. Now we check we check along I plane. We check limits along y is equal to x squared. Now along y is equal to x squared, in place of y I'll put x squared. Then I'm going to get limits as x approaches 0, 2x squared times x squared all over x squared plus x to the power 4. Now this becomes limits as, okay, the top becomes 2x to the power 4 all over x squared plus x to the power 4. That is limits as x approaches 0. We can factorize x squared out and we'll cancel, and I'll have limits as x approaches 0 to x squared all over 1 plus x squared. All over 1 plus x squared. And when x goes to 0, this will also go to 0. Because 0, 0, I get 0. Okay. The example I wanted to take, I got it wrong. If you look on the slide, the x is 4. I got it wrong. So I'll just correct it and use just x is 4. But as it stands, this one here is correct. Now I'm getting 0, 0, 0, 0 throughout. It does not mean that the limit is 0. But I'll get back to that one later, right? So pardon me, and let me just change this side here to 4. to conform with the example on the slide. Okay, so here is 4. If it is 4, then I check along limits along x is equal to 0. Along x is 0, I'm going to have limits as y goes to 0, 0 all over y squared, which is 0. Along y is equal to 0. Along y is equal to 0, I'm going to have limits as x approaches 0, 0 over x4, which is also equal to 0. Okay, I check limits, I check along y is equal to x squared. Now if y is x squared, right, then I'm going to have limits as x goes to 0. In place of y, I will put x squared. So I have 2x squared times x squared all over x4 plus x4. And this is going to give us 2x4 all over 2x4, which is equal to 1. Clearly, you could see that the limits does not exist because along x is equal to 0, I had 0. Along y is equal to 0, I had 0. But along y is equal to x squared, I had 1. So we conclude that the limit does not exist. Okay.